Last time, I added a nice world generator to my Minecraft clone that includes biomes, caves and nice structures. I think that it is time to add some nice shaders to it. For now, I would want to have nice physically based shading with lights and all. Sunlight with shadows, a very nice water shader, and some other bits and bobs. Before I bought this laptop that I have right now, I had quite a weak one, so I was barely able to play Minecraft. So you can imagine that the first thing I did after buying this laptop was to install Minecraft with shaders, and it looked amazing. It only ran at like 30 FPS though, so for my clone, I went to make it run at a better FPS while still looking great. So let's boot our clone to see where we are, and oh, we don't even have normal lights. Okay, that will be fun. At least I implemented transparent geometry. So lights in Minecraft use a float fill algorithm. Basically, each light source starts at a maximum value of 15, and it goes down with every block. The skylight works the same, but it is stored as a separate number. And when the light is at maximum level, it will go down without decreasing in value. Now this is much more complicated than it sounds, but I borrowed some help from another YouTuber that linked a nice article about this topic in his video description. Now, my lights still did not want to work, so I did the one thing that programmers dreaded the most. I coded something to help me better debug my program. I added these numbers that I can paste on top of blocks to essentially see the light values of any face. Then, while I was trying to optimize something and make filling the light downwards first, this actually randomly fixed my lights, so you know what they say in programming. If the code works, don't touch it. I searched online for a PBR Minecraft texture pack. Our texture pack from now on. And PBR just means that it has material information to make them look very nice. They all came in separate textures, and I didn't want to stitch them all in a big texture atlas, because well, I'm lazy. But fortunately, I don't have to. I will use bindless textures to be able to easily access all of them in my shader, and this comes with another hidden benefit. It removes these ugly artifacts that happen when using texture atlases. So I just slapped the PBR rendering equations from my 3D engine to get to this. Yet another benefit is that with this approach, I can use textures of any size. But I'll show more of this later. It looks better, but I still needed point light sources. So I did glowstone. At this point, things became quite complicated, because I needed to somehow send all of the light sources to the GPU and stuff. So to make this video simple, I will make a separate one where I will explain in depth how all of these graphical things are implemented and optimized, so subscribe if you don't want to miss that. It is not plausible to have shadows for all of the lights in the scene. So I used the trick in my shaders to compare the light value from the float fill to the current light to get an approximation of shadows. It is plausible, however, to have shadows for only one light source. Shadows for only one light source is relatively cheap and can be applied for the sun or the moonlight as long as they are not both in the same time. Just copy the implementation from lobnopergen.com and adapt it to your infinite Minecraft world. Order shadows for only one light source now for only $9.99. But wait, if you order now, we will include soft shadows for the same only one light source for the same price. Just copy the nice looking optimized shadow code from your 3D engine and you are done. Okay, jokes aside, now I still have to fix some things about the shadow, but it will take a lot of time. Fortunately, I have enough time because I will actually use this project for my master thesis. OG subscribers probably remember that for my bachelor's thesis, I did my game engine with Minecraft Dungeons. So it was only natural that I will do Minecraft for this one. And the good part is that now I can work on my project as my master's task, so there will be many videos coming about this project. One question that really bothered me for a long time was if I should make the renderer deferred or not. Basically, a deferred rendering engine will render the geometry first into an intermediate buffer, and then do the lights calculations. This will reduce the cost of overdraw, and it is important when you have expensive light calculations like PBR equations. The thing is, I'm lazy, as you know, and guess what? It saved me again. That's 2 for me, 0 for hardworking people already. There are modern engines like ID Engine 7, aka Doom Eternal, that don't do deferred shading. They use something called depth prepass, where they basically render only the geometry into the depth buffer first, and then they render it again, changing the depth equation to GL equals. Essentially, only rendering fragments that will end up being visible. I will make a separate tutorial on this soon. To measure the performance, I created this nice profiler that will tell me visually how much this system takes. Now it seems kinda broken if you look at the total milliseconds and the FPS. And that's because I forgot that you can't profile OpenGL as normal. You see, graphics APIs are massively latent, in the sense that they defer a lot of work in another thread to keep the application working as fast as possible, instead of stalling the process for every command. But when you call swap buffers, the driver will usually have to complete a frame. So I just changed the profiler to measure the entire frame from swapping the buffers to getting back to gameplay code, to get some results that actually make some sense. And with this, we only have water and moving blocks to talk about. I already have moving blocks, but they just look horrible. So I found this Discord server called Shader Labs, where there are basically people making shaders for Minecraft. So I asked them to help me a little, and after making their code my own property, I have these nice leaves and grass animations, and it turned out easier than I thought. Speaking of Discord servers, some people from my server randomly decided that they want to be in the next video, so here they are. Bonus points to them for the Among Us memes. Now finally, we can take a look at the water. So I followed this tutorial, and the main idea is to render the bottom of the ocean into a texture, and when rendering the water, use that texture to sample the information from below. Now you can apply this texture called the DUDV texture to slightly move the sampling point to get this nice effect. I just do something similar for normals to get these nice specular reflections. Now, to determine what is the bottom of the ocean was a little more difficult. I first rendered the opaque geometry, then I render only the water on top, but only the depth values. Now I render only the transparent geometry, that is underwater, and to do that, I use the depth values that I have just generated to only render things below them. Finally, I have a texture with what is below the water, so I can render the rest of my transparent geometry, including the water and what is above. I also made this nice caustics effect by applying a texture on top of the lights calculations. I have a tutorial about this effect if you are curious. And this is the final result. Again, I will make a video that goes more in depth and, of course, part 2, where I'll make it look even better. And I still haven't touched explaining in depth how multiplayer works, so subscribe because many interesting videos are coming. Share this video if you found it interesting, and now, I'll show you some nice shots.